Karin Stieldorf from the Technical University, and you introduce more of the whole title. It's the Institute for Architecture und Entwerfen. This is German, okay. Institute for Architecture and Design. The group, the working group for sustainable building on the Technical University Vienna. And I hand over this microphone.
Well, first of all, thank you very much for the invitation. I appreciate very much to speak about what is happening at the university. It doesn't take, we're not that often invited to speak about that. Well, I wrote the presentation in German because I thought it would be in German, but I will speak in English, so those who do not speak English will have all the writing in German, and I will speak in English. Well, sustainable building came out in the end from building physics, and at our university. It started all with Professor Panzhauser, and I think at the moment we started quite early, and I think at the moment we're not really doing enough in that direction, so I'm very happy about or the group that Paul will present afterwards, because I think this is somehow a tradition that has started and will go on with this. Well, our first project where we tried to work together in practice was a competition launched by the Future of Building, by the ministry. And normally only architects can take part, but I organized that also students can take part within a course of the university. And the big surprise was that we won and we could really realize a project. So this was for a long time, this was Schiestlhaus on Mount Hochschwab. It came out from a course at the university, and the student who made the design could also follow the whole process. And she came from the Tyrol, and she always went up and down. And for a long time, this was the passive house situated the highest in the world on Mount Hochschwab. Now there's another one built by the Swiss University, ETH. It's a little bit higher, Monterose-Hütte, and it's also done with students. So I think I'm very proud that they took up the challenge and really did the same thing. And for the first thing, there also was a wall made from clay, because this wall should be the warm wall when you come in from outside, to have an area where you can warm up. Another project, this was Gaudi competition. It was launched in Paris. Maybe our French friends know this competition. It was European-wide. And the project that the prize was to be at the Biennale in Venice. And of course, every architect to be at the Biennale, this is something really great. So this, and in the end, this really happened. So we won this competition, and the two students could build up their project really in front of the Giardini in Venice. But the project itself, of course, it is already a design-build project. It is made from pallets that you can find everywhere. And normally these are just burnt. You don't use them anymore. But these students invented a system. It is a patent. It was also it is in German patent. It is a way how to use 3 pallets in a row to build a new wall. Inside, of course, there is also ecologic insulation. Also, the lighting is inside, all the installation. By now, this house has been rebuilt in the Blue Lagoon in Vienna, which is a prefab houses exhibition park south of Vienna. Another project built for Ituba Skills College. There was a green politician who launched a village in South Africa for where young people are educated a little bit like JUMP to learn how to do many things that they cannot learn in schools, or very often schools are too expensive for them. So this and Christoph Korher started this village by the aid of different universities, and groups of students built the buildings there. So this was our building. It was the succeeding building after the Palettenhaus. It is built from pallets, and all the materials except the metal sheet is also recycled materials, of course, and perhaps except also the wall built from clay and straw. The insulation already is straw for this building, and also the glazing was collected from other buildings. At that time, the big stadium for the African football championship was built, so a lot of the pieces came from these building sites. Another building, before I come to the main project that I would like to explain more in detail, was a building created for Mongolia. Mongolia has a big problem. The capital, Ulaanbaatar, was a very small village at the beginning, only 40, 50 years ago. And the government invited then all the moving people to come to Ulaanbaatar with their yurt, and they gave them a site, and they just put the yurt there. But this had the bad consequences that the towns spread very far and consume a lot of land. And in order to heat in winter, they have just very small ovens, and this creates a very bad air. So we created the task for the students was to create a building that could be, or a building system that could be set up only by two people, made from from small pieces that could be carried just by two people, and this was also presented at the Blue Award and also honored there. But it was not only presented; a bigger piece of it was really then built in Mongolia, using just also going back to tradition, using all the materials that are usually used for building there, which means the materials that are also used for the yurt, but also insulated by the waste of the wool production there. Usually when Mongolians have cattle and they have sheep, and besides meat, which is sold to China mostly, they produce wool products. But the waste is just burned normally. So this waste was, the idea was to use this waste, put it into, fabricate insulation out of it, and build a coat for the houses. Well, this was also I could also describe all these ideas in an article for the Architectural Digest this year, where I mainly talk about that there is a specific period when students in the life of architects, when they're students, they're really comprehensive. They're ready to learn about all the topics of ecologic design. And I think it's if we should really make use of this period and tell students what they can do and that sustainability and resilience is very important for the work. So this is already a picture of the building I will talk about. It is LISI. It was a building developed with students for a big competition in the US. Normally, if we talk about ecology and US, everybody thinks there's nothing happening there, which is not true. There are a lot of people really working hard on ecologic and energy efficient topics, but there are many others, like, of course, we know the president is talking differently, and of course, there are a lot of problems, houses that are built very cheap and in a standard that is not sufficient. So there is a competition which is called Solar Decathlon, which is still, I think, the most important competition in this design-build competition worldwide. It's not only design-build, but it's also about sustainability. The teams are invited. You have to apply for it. And they choose out of the applicants, they choose 20 teams from 20 different universities. When we took part, there were 2 teams from Europe, 1 from Czech Republic, from Praha University, and our team. Well, it takes 2 years for planning and realization. Normally it's small houses. Of course, you have 10 days to build the house, so houses cannot be too big. But from the beginning, we also thought about this, that the house that we bring there and design should also be multipliable and could be put together as a double house and used also for residential settings. But beside, of course, design and energy efficiency are the topics, but also organization and the financing, which is not that easy. I think Paul will tell a little bit about this later. Well, at the end, there is a 2 weeks final with the 20 best teams. In our case, it was in California. Now it's in Denver. Before it was in Washington at the Great Mall. And there, all the houses that have been developed over the 2 years are built up. And of course, they have to be run by the sun. And then they are ranked in 10 disciplines. That's why it's called the Solar Decathlon. These are the different contests. They change by time. When we took part, it was in 2013. It was architecture, market appeal, engineering, but also communication, which was very interesting. Of course, affordability. 2 years before us, there was a German team, and they needed as much money, just for the transport to go there as we had in total. So I think this was a very interesting change, and it really also moved a lot. Then comfort, we built for people, so people should feel comfortable in houses. Hot water, which is perhaps more important in the US, because also the appliances and should be chosen in the right way. Then, of course, the energy balance, because the whole building should be run just by the sun, and home entertainment. Well, this is a little bit how the setting looks like. You get a big book, and all the rules are in there. So you have really to read it carefully, and also change from Fahrenheit to degrees Celsius, so there's quite some interesting things just resulting from building a different country. We decided to have a border around the house and bring everything that was needed for the house to the US. Well, at the beginning, we were a very small team. There was a funny thing. It was our a German colleague from teaching sociology. He told me, well, if the German team could go there, and why don't you? At that moment, I was really a little bit frightened in front of all the work, but in the end, I really said, well, maybe he's right, so let's do it. And then we set up a team not only from Vienna University of Technology, but we needed also other disciplines, so it was already in direction of integral planning and integral architecture. There were colleagues from St. Pölten who did media and communication. We had a colleague from Linz who did electricity, colleagues from Salzburg who cared for the wood construction. Because this is, of course, something that we are not used very much to do. Most students do not know how to saw and how to carry and how. So this was. But in the end, not only the male students knew how to do it, but also the female students knew it very well. They liked to use the machines. They were really fond of it. And the colleagues from Salzburg, the wood carpenters, they liked to teach our students, especially the female students. So first we developed the concept. You would not believe it, but we drew this house, I think, 1,000 times until it got that simple as it was in the end. On the right side, we also thought a lot about the surrounding envelope. In the end, it was an envelope, but we had a lot of different proposals how to surround the house. The students learned how to build in the models. The students also trained to work together by taking part in a female running competition in Vienna. Of course, the team grew and got bigger. There was even then a student from Graz. We already worked with building information modeling, which was not that common at that time in Austria. It's just getting more common. This was, in the end, a big team which had to work together from different universities, but in the end, it worked very well. We had to look for sponsors. That was our part. Even the students were even trained to call the companies and talk with them and get sponsoring. Well, then the concept. We thought we would make wooden construction because there's a lot of wood in Austria. Only a wooden building could be carried from Austria to the US. The building should be ecologic. It should be run by renewable energies, and of course it should be sustainable. So the main idea was to think about the tree, about the carrying and the branches, and to develop the house like a tree. So all the parts of the tree should be used. The bark, the timber, but also the sawdust. The bark also was worked for a cladding in the interior, the massive timber for construction and surfaces, and there was even made furniture from the sawdust. From the design philosophy also said that the house should be a plus energy house. And for this, it is necessary to also work with simulation tools. I spent 10 years at the Institute of Building Physics before going back to the designing institute. It was quite interesting because we thought the house should be possible to use the house also coming back, and it was interesting to design a house that would also work later on in Austria. And of course, there's less energy you needed in summer in California, in winter in California, but it's much more used in summer for cooling. But on the other hand, when you need the cooling, you also have a lot of energy from the sun. So it's just a few words about design philosophy. It should be possible to add the building to a row. It should need only small space. It should be energy efficient. It should be possible to. It should be a flexible building that you could use in different ways in winter and in summer. It was a small building, so there was a very reduced sleeping area, but a spacious living area. So this is LISI. We gave it also a German name, which could be easily kept in mind. On the right side, you see how well it is insulated. It is, of course, it could have been insulated with straw. There could have been more earth building, but it would have been too difficult to transport the prefabricated earth elements from Austria to the US and then rebuild it there, because there would have been too much humidity in the house, which was measured there. So there was the sleeping area and the sanitary area were transported in one piece, and also the kitchen and storing area on the left side. And the rest is just a very big, spacious area that could be opened to both sides. Sorry. A section through the house. Then show how that you can also close the whole area, the whole house, including the patios on the south and in the north, and producing more privacy by that. Also, the shadowing on top can be put away. It can be is automatically used, so that it can be shadowed in summer and without shading in winter. Everything was prefabricated in Austria. It is a modular system, lightweight wood construction, and it was all dimensioned on the size of containers. Because, as I said before, otherwise we could not have managed, because transport has to be very reasonable. So only 6 containers had to carry all that we needed for building and the building itself. So this is the steps, how it was built up. This is the hall that we got from a company to produce the house. We started in February. The students, we rent the house. Students learned how to live together. We could not build at the university, but in the end it turned out that it was better not to work at the university but to work in Carinthia. So then it was put into the containers, brought to California, and there we had a site, which I chose a site in the north, so that people walking by saw the nice facade oriented to the south. And there are much more pictures of the building phase in the internet, in Facebook. So if I can look it up. There are many, many pictures. But of course, also the team had to be trained concerning safety. Health and safety was very important during the building period. There we learned a lot because normally we do not take care enough about this. We'll also learn to use a fire. I don't know the word in English. Extinguisher. So I never used one before. So make it just a little tour through the house, entering from the south along the covered gangway. This is the picture how it looked in the end, also surrounded by plants that we rented from a nursery there and gave them back afterwards. The big sliding doors in south and north. People could come there and visit the house after it had been finished. This is the entering area with where also the house was explained. We also see vertical farming a little bit because even in a small size, there was no color used for the house. All was made from wood. Even the only picture in the house was a very beautiful table. These were the covered patios, which is an element quite common in the south of the U.S., coming from the Latin American building tradition. The bathroom connected with the sleeping room. This is the cladding made from bark. In the small patios, we also had small gardens with plants from California. Also, of course, housing technology had to be well planned and well thought over. There was a double floor, integrated ventilation, and the energy was produced by PV on the roof, not visible at first sight. There was even a shower, energy efficient shower. The heat from the water, from the used water, is given over to the fresh water. This is the roof with the photovoltaic system, which supplies the whole house. Of course, simulated before, otherwise you don't know how many panels you need. So this is the comparison between Austria and California. On the bottom, you see the demand is not that different over the year. It's a little bit smaller in California, but not that much. But the gains are much bigger on the right side, on the bottom. This was the contest, energy contest. The more you can see very well that we had by far the best results. We had, of course, we had a very good building envelope and enough PV and a very well worked out system. It also was certified. It was the first Solar Decathlon project that was certified also by LEED, not only by Austrian and German. It was DGNB, the Austrian ranking system, and the US system. So platinum and gold. And the principles were, just to sum up, ecology, economy, but also socio-functionality, a steering system also developed to work on an iPad for running the building. Of course, high technical quality. We only worked ourselves. There were some other teams who had the help of companies, but we really only worked by ourselves. Following very well, having a very well worked out strategy before. Which was interesting was the Gerüst, I don't know in English, scaffolding, was much admired. They didn't. We were the only team who had that modern scaffolding. Media and communication, we had branding, which was very important, a good name and a good branding. We also had, it was then opened, and the son of architect Neutra visited us, so we're very proud about WIPS. We have, of course, we are present in the internet, in Facebook and on a homepage. Afterwards, we reconstructed the house in a prefabrication area south of Vienna, where you can also visit it. And now I run really over it. There's a small catalog now developed with different sizes. Sorry, the wrong side. 60 square meters, 80 square meters. LISI Blue because of Blue Lagoon. 120, 150, and also 2 levels. It was not that easy to keep the style, also for other sizes, but also optional other, so you can also do it. There's also a DIY version already. And only a very few slides at the end, how I started to get into the topic. There was an excursion to Mali. It's nearly 20 years ago, it's 17 years ago, where I met for the first time how to work with earth. And this also was our first workshop with students. They could take part in the building of the French Culture Institute there, and first mount a scaffolding to work on a wall. What we do now is also working in workshops here in Austria, but also in Iran. This was our excursion this year to Iran. We tried a Nubian vault there in a small size, and students can really touch it and work with it. These are the last slides. It's a project. Also, we have. It was also a design course for Ethiopia, and one of the projects really was built by 2 students.